All right, so in this lesson, we're going to be doing here is we're going to be using the tangent ratio again. But this time we're going to use the tangent ratio to calculate the lengths of, or calculate this, yeah, the lengths of sides. All right. So, um, yeah. So let's just jump right into this first example. All right. So determine the length of xy to the nearest tenth of a centimeter. All right. So xy from x to y, this side right here. This is the length we're going to try to find. So I'm just going to label it x. All right, so yeah, so to find the length of x, our first step is the same as it was in the previous lesson, where we're going to label the sides. All right, so when we're labeling the sides, the side that I like to start off with is the side across from the right angle, which is our hypotenuse. And if you recall, the opposite and adjacent side, they depend on the angle that you're working with. All right, so in this case, we're working with this angle here, which is 70 degrees, which makes the x our opposite side, because it's across from the 70. And this 5 centimeters here, 5.0 centimeters, is our adjacent side. So this is how you would label this triangle. All right, so once we've done that, what we're going to do next is we're going to set up the equation. All right, so if you recall, tangent is equal to opposite adjacent. All right, so in this case, what I'm going to write here is I'm going to write tangent of 70 degrees. All right, so in the previous lesson, right, we had we'll write down theta because that's the angle that we're trying to find. We're trying to find angles. But for this lesson, what we're actually given is the measure of the angles, and we're trying to find the length of the side. All right, so what that means is when I set this up, I'm going to write tangent, and I'm going to write the angle that's given or working with, which is 70 degrees. Now this is going to equal, and for the opposite side, I'm going to substitute the variable x. And then for the adjacent side, 5.0 centimeters, or just 5. Okay, so this is how the equation is going to look. Okay, so we want to solve this equation. Now, tangent of 70 degrees is actually a number. So that's kind of the key thing here. Is whenever you see a tangent in an angle, what you want to do is you want to just regard this as a number. All right, so if that's the case, and if I want to solve for x, or I want to isolate the x, what I'm going to do here, to solve these equations before, is I'm just going to multiply both sides by 5. All right, so that this cancels with this. And therefore, x is going to equal 5 times the tangent of 70 degrees. All right, so the way you would do that in your calculator is open this up. I'm going to find the tangent of 70 degrees, so I'm going to punch in 70. And then instead of hitting the second function here like we did with angles, I'm not going to touch that. I'm just going to punch in 70. And you'll notice here it's equal to 2.7474, blah, blah, blah. All right, so that's what tangent of 70 degrees is equal to. So 2.747. All right, so we'll write 5 times 2.747 dot, dot, dot. Right, so again, this number here is the tangent of 70 degrees. So to that, I need to multiply it by 5. So I'm going to multiply this by 5. And x is going to equal 13.7. If I round to 1 decimal place, 10th of a centimeter. All right, so x is going to equal 13.7 centimeters. Right. The other thing, too, is that when you're doing these calculations, you want to leave the rounding to the very end. Okay? Rounding to the very end. All right, so what I mean by that is we don't want to round the ratio of this step, right? We want to round it at the very end. The reason for that is once you start rounding earlier, then your answer is going to be off by more than if you were to just round it at the very end. Right, so once you punch, if you were to punch in tangent of 70 into your calculator, what you want to do is just leave it in your calculator to how many decimal places it goes, and then multiply that by 5, and then round the answer. So you'll see here, yeah, so this turns out to be 13.7 centimeters. Cool. All right, so let's try another one. Okay, so again, we're going to determine the length of Vx to the nearest tenth of a centimeter. Okay, so Vx is this line up here, so let's just call that x again. All right, so first step here, I'm just going to label the sides. So this is my hypotenuse, this is my opposite side, this is my adjacent side. And again, 42 degrees is what the angle that we're working with. So tangent 42 degrees is equal to opposite, which is 7.2, over adjacent, which is x. Now, what you'll notice in this equation is that we're actually, this time we're solving for the adjacent side. Now, in the previous one, we were actually solving for the opposite side. Okay, so when we set this up here, the x was up top in this example. You'll notice here the x is on the bottom for this one. Now, we're still going to do, still going to solve for x, but this one here is actually going to require 2 steps. All right. So the best way to, or the first step that we're going to do is we're actually going to get rid of the x here. So what I like to do here is actually set up a cross multiplication. All right, so tangent of 42 degrees, I'm just going to write it as tangent of 40 degrees over 1. All right, so anything over 1 is itself. And this way I can just set up a cross multiplication. So when I do that, x times tangent of 42 degrees is going to equal 1 times 7.2, which is just 7.2. And then to solve for x, on the left-hand side here, this says x times, right? So it's implied that you're multiplying, right? X times tangent of 42 degrees is equal to 7.2. Well, the opposite of multiplying is to divide. So I'm going to divide both sides by tangent of 42 degrees. All right, so what that does is on the left-hand side, these cancel. And therefore, x is going to equal the 7.2 divided by tangent of 42 degrees. All right, so I'm just going to show you how to punch that into the calculator. All right, so basically I'm going to go 7.2 divided by, now the tangent of 42. For this calculator, I got to punch in the angle first, and then tangent. All right, so right now this is displaying tangent of 42 degrees. Now to actually get the answer, and as a result, yes, 7.996, which actually rounds to 8.0 to the nearest 10. So 8.0 centimeters. All right, is going to be the answer. All right, guys, cool. That was a fairly quick one, hopefully. Yeah, so that's using the tangent ratio to solve for lengths.